welcome to Danny's Maths Hub, where we are continuing on with speed, distance and time. And today is all about time. But before we begin, I'd just like to remind you to hit that subscribe button if you are enjoying or learning from these videos I am making. I really appreciate it, and it's a great way to help out this channel. Anyway, let's get back to time. Now, time seems like quite a universal thing. We measure the life of the universe in years. We measure our days in hours. We measure certain things in minutes. Each lesson is measured to be an hour or an hour and a half at school. But actually, time is very, very unique in the way that we use it. The way we use time on this earth, well, this is the only planet our time would work. Using 100 milliseconds in a second, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year. That wouldn't work on any other planet other than Earth because of the size of the Earth, the speed we're spinning, the speed we're orbiting the sun. That's the only way our system works, is because of all those speeds. Now, to find another planet out there that matches all of that is very, very, very unlikely. Not impossible, but very unlikely. So our time system is very much an Earth time system. And it's really important we know how we can convert between seconds, minutes, hours, especially if we want to move on to look at speed and at calculating speed from different distances and from different times. So let's have a look at some world records. The world record for doing a 200-meter sprint wasn't set by me in the last lesson when I went running. It was set by Usain Bolt, and he did just over 19 seconds. Now, 19 seconds is impressive. I mean, that's under 10 seconds per 100 meters. That's the speed I can't even fathom. However, there is other ways we could represent this time. We could represent 19 seconds as a minute. But obviously, it's less than 1 minute, isn't it? Because there is 60 seconds in a minute. So we know that this is going to be 0 point something because it's less than 1 minute. But how do we convert seconds into minutes? Well, it's the same as yesterday. If we know there are 60 seconds in a minute, and we are going from a smaller unit, so seconds, up to bigger units of minutes, we divide by 60 because there is 60 seconds in a minute. So 19 divided by 60 is 0.32. Now, the reason I'm going through this is because a lot of people, and I'm not saying you definitely would have, but a lot of people do tend to just put 0.19. Now, unfortunately, we can't do that with time, and it's because of our unique timings. There is 60 seconds in a minute. If there was 100 seconds in a minute, we could simply put 0.19. But because it's 60, it means the total is out of 60. Hence, 19 divided by 60. We divide it by the total amount. So Usain Bolt's world record run of 200 meters is 19 seconds, but we could also say it was 0.32 minutes. Let's have a look at another record, the record for the fastest person ever to run 10,000 meters, which, if we use what we learned last lesson, is 10 kilometers. Well, the fastest man ever to run 10 kilometers managed to do it in just 26 minutes. So we managed to run 10,000 meters in just 26 minutes. What if we wanted to represent minutes as seconds, though? Well, we're going from minutes and we're going down to a smaller unit of seconds. So we're going to multiply, and how many seconds are in a minute? 60. So we do 26 times 60, which is 1,560 seconds. So he ran 10 kilometers in 1,560 seconds. Now, what about if we wanted to represent that as an hour? So 26 minutes as an hour. Well, again, we're going from minutes to hours. So we're going to a bigger unit. So we're going to divide. And how many minutes are there in an hour? Well, there are 60. So we have to do 26 divided by 60, which would give us 0.43. So he ran 10K in 0.43 hours, which, if you think about it, 30 minutes is half an hour, which is 0.5. And he ran 26, which is just less than 30. So it makes sense that the decimal is just less than 0.5. So that's how we go between seconds, minutes, and hours. If we're going up the units, so seconds to minutes to hours, we're dividing. And if we're going down hours to minutes to seconds, we're timesing, just like we did with our distances yesterday. Now, this is going to be really important for calculating distances. And what we're going to have to do a lot of is turning hours and minutes into just hours, or minutes and seconds into just minutes. And what do I mean by that? Well, let's have a look at a car journey. Let's say a family were going out for a day and it took them 3 hours and 30 minutes to get somewhere. If we wanted to calculate their speed, first of all, we'd need to know their distance, but I'm going to explain that in the next lesson. But we can't put 3 hours, 30 minutes into our calculator to do any calculations. We need it in just terms of an hour. We've currently got 3 hours, 30 minutes, and we want it just as hours. So how can we convert that? Well, 3 hours means we've got 3 whole hours. So we don't actually need to convert that. We can leave that as it is. It's 3. But then we have part of an hour. We have 30 minutes out of the full hour. Well, to write part of something, we use a decimal place. So we've got 3 point something of hours. But we know how to turn minutes into hours because we've just done it. We do 30 divided by 60, which gives us 0.5. So we have 3 hours and 0.5, so we just add those together to get 3.5 hours. Let's say this time, the car journey only took 1 hour and 43 minutes. Well, again, they've done 1 full hour, so we've got 1. And then they've got 43 minutes, which is a part of an hour. So there's going to be 1 point something. Well, how can we work out what it is? Well, we turn our minutes into hours. 43 minutes into hours, we divide by 60. 43 divided by 60 is 0.72. So we put our 1 and 0.72 together to get 1.72 hours. Now, what about if we're working in reverse? What about if we look at the longest commercial flight we could possibly take, which is 18.5 hours? How can we then write that as hours and minutes? Well, we know we've definitely got 18 full hours, so we've got our 18 hours. What about if we wanted to represent that now as 18 hours and so many minutes? Well, we have 0.5 hours, don't we? And we know how to go from hours to minutes because we multiply by 60. So 0.5 times 60 is 30. So we have 18 hours and 30 minutes. Now the key here is breaking it down into the wholes and the parts. What about though if we just wanted to simply break this down into minutes? We've got 18.5 hours. How could we represent that as just minutes? Well, we're going from hours down to a smaller unit of measure, which is minutes. So we're going to multiply by 60. 18.5 times 60 is 1,110. So that flight takes 1,110 minutes. What about if we then wanted to know how many it took in seconds? Well, again, we're going from minutes to seconds. So 1,110 times by 60 is 66,600. So that flight takes 66,600 seconds. So if you're taking that long flight, if you just count up to 66,600, well, then your flight will be over by the time you got to the end. Let's now look at the shortest flight you could possibly take. Now, the shortest commercial flight you can buy tickets for takes 1.5 minutes. So what is that in just minutes and seconds then? So we've got 1.5 minutes. What if we want to know what it is in minutes and seconds? Well, we've got 1 full minute, haven't we? And we've got 0.5 of a minute. So we're going to go from minutes to seconds. So we take 0.5 times it by 60 to get 30 seconds. So it takes 1 minute and 30 seconds, that flight. Well, what if we just wanted to know it in seconds? Well, we've got 1.5 times 60. So it takes 90 seconds. That's right, the shortest flight you can buy a ticket for takes 90 seconds. By the time you've taken off, you'll be landing again, I reckon. Let's have a look at one final example then. The world record for climbing to the top of Mount Everest is 8 hours, 10 minutes. How could we represent that as just hours? Well, we've got 8 full hours, and then we've got 10 minutes, which is part of an hour. How can we turn How could we turn our part of an hour into a decimal? Well, we have 10 minutes. So we do 10 divided by 60 to turn it into an hour, which gives us 0.17. So we have 8 full hours, 0.17 of an hour. Now, this scale is all very, very important, and it's about breaking it down into your wholes and your parts. This does take some practice, okay? This is one of the questions that do slip up a lot of students, okay? Whether they're in year 11 doing their GCSEs or whether they're in year 6 doing their SATs and everyone in between. Time is a funny concept for us to get our head around because we're used to working in powers of 10, whereas now we're working with 60. As long as you remember these fundamental things, that there is 60 seconds in a minute and 60 minutes in an hour, and we know that when we go up a unit, so from seconds to minutes to hours, we're dividing, and when we go down the units, hours to minutes to seconds, we're multiplying. As long as you can remember that, then you should find these questions easy. But it all comes down to practice. And talking about practice, I have attached a worksheet below, so please do click on the worksheet, and the answers are also attached. Don't forget to hit that subscribe button if you haven't already, and have a fantastic day.